Dear AS or A-level students, hi everyone again. I wish my dear students, specific students, are still motivated and following the videos. We advise you to keep learning and watching the lessons and all the subjects, not only maths or mechanics, to do good in your tasks and to spend your time properly. All right, we finished the last part, second part of moments. We are in the chapter of moments, and we finished in part 2, solving problems involving or about uniform bodies in equilibrium. Today we are finishing the chapter of moments by solving two past paper problems involving non-uniform bodies resting in equilibrium. The main steps, which are two steps that I explained to you in the first page here, will not be different. We'll be constructing two equations. First equation with the forces upwards equals to the forces downwards. The sum of forces is 0 in the system. Second equation, to remind you quickly, it's the equation about the moments taken about a point. The moments anti-clockwise is equal to the moments clockwise. Okay, what's the difference? Let's see the difference only between non-uniform bodies and uniform bodies that we did last time. First question, which is the year October. This is October 2018. IAL is that I started with, which is question 2. Question 2 saying a non-uniform plank AB has weight 60 newtons. Look what I'm doing. I'm reading. Since we said non-uniform, so directly we place the weight of the plank or the rod not in the middle. So it is X meters from any point. But since we start from left to right, the best to do, or for convenience, from this to A, from this position to A is X. So this is the distance between the weight of the plank from A. The plank rests horizontally in equilibrium on two smooth supports, A and C, where AC is 3 as drawn in the diagram. A parcel of weight 12 newtons is placed on the plank at B, and the plank remains horizontal and in equilibrium, remains straight. The plank remains straight or horizontal. The magnitude of the reaction of the support at A on the plank is half of the magnitude of the reaction at the support at C on the plank. By modeling a plank non-uniform rod, and the parcel is a particle, means it has a mass, it acts. And this is the reasoning, like you'll see now in the second part in the question. Find the distance of the center of mass in part A of the plank from A. So he told me here, state the distance from A, like I did in the question. Usually we do this, but he said this now in this question. Alright, let's start solution. Part A. What do you want in part A? So he wants the distance x that we show it here in the diagram. We have two steps, we said. First step, we write the equation of forces. The equation of forces that is He told me now the reaction at A is half of the reaction at C. So you write this, reaction at A is equal to half the reaction at C. It's better to write what are you given in the question. So the first equation, RA upwards, RC upwards, we add them, is equal to 60 plus 20 newtons plus 12 newtons. 60 plus 12 newtons are downward. So what you'll by replacing now, RA is equal to half RC, just you put instead of RA half RC plus RC is equal to 72. By solving this for RC, 1.5 RC is equal to 72. This will give you RC is equal to 3/2, 48 newtons. Calculate this in the calculator, of course. So RC from the first equation is 48 newtons. Second equation, by taking the moments at any point, since he said from A, especially we are free, we said, remember, free. We can take it at A, at C, at B, any point on the plank or on the rod. So you'll be taking it at A, moments clockwise is equal to the moments anti-clockwise. So R at A, here the reaction at A will not be affecting the motion because the moment of it is 0. Don't forget this fact. So the first one is 60, which is clockwise. Do this like I did. Look, the arrow, state the direction of the force about the point that you select to take the moment about. So 60 times the distance, which is x that we are finding. We have another force in the same direction, which is 12 newtons. The distance is the length of the plank, which is 5. Distance between here, B, and A is 5, is equal to RC, it's the only force. The distance between C and A, he told us in the question, is 3 meters. So times 3. By replacing RC by its value, what you'll be getting here, so this is 60x, 60x plus 60 is equal to 48 times 3, which is 144. So this will give 60x. 144 minus 60 is 84. So x is equal to 84 over 60, which is 1.4 meters. This is the center of mass from A, on the plank or off the plank from A. Part B, we can answer these questions only by reading the question well. He says, state briefly how you have used the modeling assumption that is in equilibrium. State that the parcel is a particle. What does this mean? What does he mean by this question? What did we assume? We assumed two things. That the parcel, like he said, he is a particle, and the plank remains horizontal when we add this force. So only in simple words for part I, B part I, the parcel is particle, since the weight of the parcel acts at B. Finished. Since it has a weight, so it acts. It does act. It has a moment about A. So it is a particle. It has a weight. Part 2, the plank is a rod. Remember what is the rod? It's light, rigid body. Yeah? So whatever happens in the motion, the plank, which is the rod, why it's a rod? Because it remains horizontal. Or straight, you can say. The plank is a rod because it's a light, rigid body, solid. Okay. Second and the last question for today, because many students complain about, oh sir, the lesson is like long, so we'll do only 2 questions. They are enough to understand well. If, of course, you see this not enough, but I think these 2 questions, I select them, they may help you with the non-uniform. We have a bit harder problems, we'll be doing them in full past papers soon, inshallah, after we finish vectors. Alright, this is question 7 from January 2018. The 7th question. The question says, a non-uniform rod is a different way in asking. Of rod AB has length of 6 meters and mass of 8 kilograms. Before we continue reading, look at what did I do. So we have 8G, the mass, be careful, the mass is 8 kilograms, so the weight is 8G. The rod rests in equilibrium in horizontal position on 2 smooth supports at C and at D, where AC is 1 meter as shown, DB is 1 meters. The magnitude of the reaction between the rod at the support D is twice the magnitude of the reaction between the rod at C. The center of mass of the rod is at G. He called it the center of mass at G. So label it, label everything he says. So it is G, where AG is X meters, like we did here, X meters. Show that X is equal to 11 over 3. Show that X is equal to 11 over 3, part A. Remember even from the second part, the previous, when he tells us in the question we have relationship, algebraic relationship between the reactions of the supports. Don't write many symbols, many letters. He said the reaction at D is twice, so write the reaction at CR. Don't write RC and RD. If you keep them RC and RD, you are telling we have 2 unknowns. You will stop, you will be confused. You will not continue properly with solving the question. So I mean, since we can write it here to explain to the examiner if we have time in mechanics exam, which is like it doesn't happen regularly. So he said that RD is twice RC. So when you write that, does it make sense? You write RD, this is R, so the R at D is 2R, like I did, 2R and R. Then we started solving as we know. We don't care about, how he asked us in the question. Just continue with what do you know. First equation with the forces, what do you have? Upwards, we have R plus 2R is equal to 8G. Only one force downwards for now. So this means that 3R is equal to 8G. This implies that R is equal to 8 over 3G newtons. Write G, of course, clear in the numerator. Be careful. Second equation, dear students, with the moments. When he says this in the question that AG, he guides us, he helps in these questions, which is good, that where you take the moment about. Good? We are free, we can take it anywhere, but since he said AG is X, you will take the moments at A, the moments at A. So we have clockwise and anti-clockwise. Label this. From here is anti-clockwise, from here is clockwise, from here is clockwise. So we have R for clockwise. R distance is far 1 meter from A, plus 2R, since from D to B is 1 and it is 6 meters. So between D and A is 5 meters. 5 meters is equal to 8G times X that he wants. So we have here what? 11 R times 1 plus 10R. So we have 11R is equal to 8G times X. Let me just write it in the left for the space. 11R is equal to 8GX. This implies that by replacing R by its value, 8, R is equal to 8G over 3 is equal to 8GX. Only that will be doing here G with G, cancelling each others, 8 with 8, cancelling each others. Just to make it lighter, to be clear, this implies that X is equal to 11 over 3. It's easy, 6 marks. Do you agree? Easy, 6 marks. Why I have to talk a few seconds about this. Many students, they are good like A to A star in the IGs or A level. They may lose marks here because most of them, most believe it, most of you even in the future, you write this in decimal, 8 over 3G, you write it in decimal. Of course you will stop if you write your answers in decimals. He write it in a fraction. Keep your values in the middle of the steps as fractions. Keep them. In seconds you'll get the answer, like you are seeing now. Okay, since he's introducing to B, so he's giving new information. We prefer in this case to draw the new information on the same diagram, in the same figure here. Draw a new shape now. So he's introducing for part B, he wants the support at C moved now to point F. So before you do directly, you draw another diagram, new one. So he didn't change A, he said A as it is. He said the support C is moved now to the point F, where AF is 2 meters. So F is here now. And the distance AF is 2 meters, dear students. Good. A particle of 3 kilograms is placed on the rod at A now. At A. So we have here at A we have 3G newtons. The weight of the mass 3 times G. The rod remains horizontal in equilibrium. The magnitude of the reaction. Okay, did he say anything about D? So D as it is. D as it is, and the distance as it is. He didn't change. We keep them as they are. But he told us in the question now, the new part, the magnitude of the reaction between the rod on D is K times the one at F. So if this is R, this is KR. Don't try, dear students, RF and RD. Don't. K times this at D is K times other one. Do the smaller one R and the larger one with KR. Good. And what do you have also? We know now the center of mass, it's fixed now. So G is almost 11 over 3, it is 6, it's almost here. Because 11 over 3, it's 3 and something. Or 4 minus something, so it's almost here, G. So between G and A, it's 11 over 3 meters. He found it here. He told us and we did show it in part A. So this didn't change. The center of mass does not change. Does not change. Good. He wants the value of K. We do the same, dear engineers. We do the same. For solution for part B then, what do you mean by the same? Question 1 for forces, R plus KR is equal to 3G, and we have here, of course, don't forget the 8G, the weight of the party, the plank or the rod, plus 8G. This will give me that R plus KR is equal to 11G. Directly from here, since he wants the value of K, make K the subject in both equations. Here we cannot, because we cannot make R the subject or we find it like we do in the previous question. So best to do here, put K common factor, common factor, 1 plus K equals 11G. So from here directly, R is equal to 11G over 1 plus K. And I have to tell you, we can do this in many ways. I'm doing the shortest way, maybe the shortest way. Since he wants the value of K and we have two unknowns now, we have K and we have R. Make one of them the subject of the other one. Write one of them in terms of the other one. Since we have like terms with R, we can do. So make R the subject. We cannot make, it will be complicated if you make the K the subject in here. More complicated expression. Equation 2. Now to have less steps of algebra, we have to be smart here. Remember, we can take the moment at any point. But if you take the moment at A here, which is not wrong, it's right, you'll be having force R has a moment, force KR, so you'll be having more R's and many K's in the question. So to save steps, take the moment at D in this question. And try, dear students, try to take the moment about, you'll see, yeah, it's 2 to 3 steps more, but you need this time in M1 exams. As good O-level student or good AS student, you have to know these things. You have to be skillful in these things. Alright. So you take at D. Directly you come 1/4, second, third. So the force clockwise, it's R only. The distance between R and D, between this R, it's F and D, between F and A is 2, between D and B is 1, so 3 left. Because the whole length is 6. 6 minus 3 is 3. Is equal to the moments anti-clockwise, which is 3g, dear students. 3g to D. What's the distance between D and 3g? It's all 6. Minus 1 is 5. Plus 8g. Between 8g and A is 11/3. And D to A is 5. I will write it here. From here to here is 5. It's 5 meters, yes? 5 meters. So the distance here, it's 5. I will do it in another color. It's 5 minus 11/3. It is 5 minus 11/3, which is 15 minus 11, 4/3. 4/3. By replacing R, this R by its value, you'll be getting R is 11g over 1 plus k. It's about algebra now. Times 3 is equal to 15g plus 32, which is 8 times 4, g/3. So you are noticing now that all the difference, big difference between, the main difference between non-uniform is algebra and uniform, only algebra. We have to do make k the subject now, only solve this for k, make k the subject, you will get the answer. Find the value of k. So this is 33g over 1 plus k is equal to 50. Of course, we'll make the denominators the same. So this is 45g plus 32, which is 77g/3. G with G gone. So this implies that 77 times 1 plus k is equal to 3 times 33, which is 99. So this implies that k plus 1 is equal to 99/77, which is dividing by 11, it's 9/7. So k is equal to 9/7 minus 1. So k is equal to 2/7. 2/7. Finished. Please communicate if you need help with this topic more. Just tell me that we need more questions to do. And I don't mind to do another lesson on moments, or we doing past paper, full past paper problems, focusing with the moments first. But after we finish the next chapter, which is the last chapter in this syllabus, which is vectors. As usually and as always, I wish you the best and your families. And may Allah bless all of you, dear students, and your families.